So continuing from yesterday, in which we already discussed about the introduction, what is the semantic web, what is linked data, what is the concept of knowledge graph, and how do we, what have been done in the past, the evolution of the technologies and so on. So we get deeper today into the linked data principle, and I will move forward to some key technologies starting from RDF, Resource Description Framework, and so on, okay, if time permits. So let's move a little bit to this in detail. The first thing, some of the recap, okay, this is what we discussed yesterday, okay, in terms of what the semantic web is and the vision and the goal. And in brief, right, we mentioned that it's kind of starting from the vision of Tim Berners-Lee in order to make the content of the web be in a form that machines. We use the term machines a lot, but that means computer applications, programs, and so on, to be able to process the data available in the web in the meaningful way, automate way that can assist humans to do whatever we want using those data, and try to reduce manual tasks in terms of integrating several pieces of data from here and there as much as possible. Okay, that is kind of the goal. And in order to enable this goal by the technology of the approach, the side that we say, right? We have two sides of the approach that could make this possible. One direction is to use smarter machine approach, make machines super smart. Whatever you write, whatever you publish on the web, they understand, the machines understand, using NLP technique, machine learning techniques, and so on. On another side, that is what we will learn and focus in this course, is making the data becoming available in the form that easy for machines to process and understand. So we prepare the data not to serve human only, but make the data to serve machines. Okay, that is the smart data approach. Okay, and in that way, it means that we want to incorporate formal semantics into the web content. Try to make sure that content on the web is in a form that is understood by machine, using certain formal, structure, standardized knowledge representation techniques. Okay, and that is this is the picture that we discussed yesterday in terms of related technologies that are the foundations for the semantic web, and that is why it is called Semantic Web Technologies stack. What technology stack that allow us to build applications on top, semantic web applications on the top. Okay, and okay, we will learn from the bottom up one, because so that means we will learn from the platform infrastructure first. Okay, and okay, this is a 2D version in which I like it better. Okay, first we already talked a little bit about URI, and I think you know already about Unicode. These two are kind of just the serialization level, right? To represent data, you need to encode everything in some character encoding syntax or standards, right? And Unicode is the one allowing us to represent data in any language. URI, Uniform Resource Identifier, allowing us to uniquely identify resource. Okay, any kind of resources. On the web, you have million or billion of resources you need to know that this one is different from another. Even they may use the same name. For example, we may have the same person called John, millions of John, but are they the same John or different John? Which John? Who's John? That John, and so on, right? You need a way. So URI is a mechanism for that. So after we have this layer, okay, kind of very bottom layer, on top, the very first born syntax to be the first standard syntax for semantic web was XML, but it has been evolving and a lot more of the possible syntax has been introduced. So if we go back to this picture, you will see that there will be a number of other syntax as well. We will learn additional syntax, not only XML, because XML is kind of still there, but we have more of the modern ones, such as JSON, such as Turtle, and a few more. Okay. And we will learn the data model, kind of the data model layer for data interchange. That is what we call RDF, Resource Description Framework. Okay, this is the focus. I think we go up to here if possible. And then we will climb up the stack and learn a bit upper and upper. Okay, so that is kind of the plan and the technology. We already discussed this. Okay, I skip and not to repeat everything. This is what I already mentioned in the stack and explain for Unicode and URI, XML, and so on. So please go and read this slide. Okay, some of the detail that I just skipped. Okay, then the next thing is when we talk about semantic web, linked data, knowledge graph, that is what we discussed yesterday. The key thing is actually we consider why semantic web would be useful or beneficial, because actually we want to turn anything that is available on the web into what we call them knowledge. I mean, they are pieces of data, they are content, but if you can model them as knowledge source, available knowledge source on the web, right? There's a gigantic knowledge source on the web. Then you model them properly, you can kind of retrieve, search, reason, and make use of those available knowledge to benefit whatever you want to do. Okay, so the thing that we are going to discuss next is how or what possible techniques, methods we can do to represent knowledge on the web. Okay, suppose that I have this statement, and of course this is very possible that you can find this kind of statement or piece of knowledge on the web, right? And similar things, such as Pluto has been discovered in 1930. There are many other things you can read from the web in similar manner as well. So this is not in a form that, as I said, easily understood by machines. They are in a form that easily understood by you, by us, by humans. But for machine, it requires, of course, NLP techniques to understand this. But if you want to, when we say that knowledge representation, okay, techniques, it means that, hey, how can we represent this sentence of this knowledge in a form that machine can understand? Not this one, for sure. So to represent this, you already learned several ways to encode this in machine understandable form. Some is easy, some is not so easy for machines, okay? First, I think this is what may be familiar by you. as a UML instance. UML is a very formal notation standard to represent, with UML class diagram and object diagram, you can represent this kind of simple fact as well. Okay. In HTML, I think we have seen that a lot. In XML, we will see this. Okay. So these are three possible ways, easy, familiar way, familiar for us. So these three ways are very different to do. But let's say for UML. UML class diagram allow us to represent an object, right? An object diagram. You may define a class planet. And you may define Pluto as an instance of the class. An instance or an object, right? And we may define an attribute, discover. And we say that, yes, for this instance, the discover has the value 1930. That's it. This is the way you can do in Pluto, in UML. And similarly, if you want to represent that Earth is also a planet that has been discovered in whatever year, right? I don't know what year. It must be long before, right? Discovered by us as humans. Okay. And then you can represent in UML in similar way too. And with this way, it's formal, it's standardized. Okay. It follows certain knowledge representation technique. Second way, as HTML. This is very much, we already discussed, it's not really easy for machines to understand things. It's just to represent that, okay, there is Pluto, okay, with maybe a link to Wikipedia and also as a text saying that has been discovered in 1930. So this is not very formal and structured way. The third one, as an XML, you can define a tag, planet, attribute name with the value Pluto, attribute discover with the value 1930, and that's it. Okay, that is also possible in XML. So there are various ways, but a problem in XML is that you can design and model any possible tag, nested tag or element, and so on, and come up with very different schema to represent the same thing, but it's not very standardized because different users, different persons may want to represent the same fact in very different ways, and the way to standardize them or matching them that this fact and that fact is the same will be difficult. So XML in this manner will not be considered as a good way. The same, this is not a good approach. HTML for sure is not a good approach. It's not really knowledge representation. UML, yes, this is acceptable, very good. But the technique that we will learn here will be based on RDF graph, or actually, as we discussed yesterday, will be based on the foundation, the idea that is underlying Google Knowledge Graph. So this knowledge graph represents everything in this format of, remember, yesterday we have seen a lot of examples in this form, in which we have node represented as a node in the graph. We have directed link, to represent a relationship between nodes. Okay, so this is just the pattern, which is very simple. You represent, node can represent anything. Directed link is used to represent any relationship. So with this approach, we can easily represent any form of knowledge in this way, right? Something has a relationship with another thing. So for a very simple way of encoding this statement as a knowledge graph or IDF graph, then that is why we have this. There must be a node Pluto, which represents the planet Pluto. There should be a relationship. In this case, we made a very simple one, just a text say has been discovered in, but of course later on we will need to find a way to make this knowledge representation graph in a form that is more formal. Okay, this is still a bit informal. And then the value of 1930 is another node in this graph. Okay, so that RDF graph that we said, okay, this is the underlying standard. Stand for resource description framework. So resource, as I said, can be everything or anything. Key thing in RDF and semantic web linked data knowledge graph is that everything that you want to represent should be uniquely identified by URI mechanism. Description means that in the word semantic, right? It means you want to formally describe things. That is the meaning, some of the meaning of the semantics that we discussed yesterday. When you want to give the semantics of something, it means you are describing that thing. You give the explicit description of that thing. That means you're giving the semantics. So we want a way to make a description of the resource you are interested in. Okay, so that is why the second word here, right? Resource and then description. Okay, and the way to make a description is through properties or relationships. And then, of course, the framework is another last term. That is the framework that is this whole RDF stuff is the framework that is based on a formal model having formal semantics that can be defined. Okay. And when we want to represent any knowledge in RDF, using RDF, we will express them as a list of statements. Sometimes, most of the time, actually, you will see, as we saw already yesterday, the word triple, right? Remember I said about this yesterday. Triple means statements. It's the same thing. RDF triple is RDF statements. It's the way just to refer to this specifically. And okay, here. This is one RDF statement. This is one statement having node link node form, and we call it a triple because Sometimes, okay, in the next thing, we will see that this is called subject. Later on, we will have more detail. Subject, predicate. Predicate, you can think of it as property, but the formal term is predicate. And this is object or literal. Okay, so the formal syntax for RDF in which you can expand and connect is to use this form of subject, predicate, object, or subject, predicate, literal. Usually a very specific syntax is to differentiate between object. I should not use the arrow. Is to differentiate between object and literal, because literals are just text values. Objects means another resource, another node. Okay, so to explicitly distinguish them in graphical notation, we use different syntax notation as oval or rectangle. Okay, whenever you see rectangle, actually it means literal value. So to be very precise, if I would say there is a node Shutiporn, email, I would use this, right? Because this is my email or telephone number or whatever. Okay, that's the thing. So you can see here, subject, predicate, and object are the three components in RDF statement. Okay, so back to how RDF would be fundamental technology for linked data. Remember linked data, we already mentioned yesterday that we want a way to publishing data on the web that is not in the same way as current web that is in only HTML, but we want also in a structured, standardized, formal way that machine can understand the data. So instead of having everything in just HTML, in which it is very difficult for machines to use the data, then we want data to be published in addition to normal HTML as linked data, so that it generates all these benefits, okay? And there are 4 principles for linked data. The first one, everything should have URI. Second, URI should be dereferenceable. We will see that. Third, provide descriptions in RDF descriptions. And then connect or link your data with many other data. So make the network effect. The graph should connect, right? If you have a graph, but your graph that never connects to anyone, then it's not real, it's very isolated. Okay, so the first thing, naming everything with URI. Meaning that anything, remember when we talk about data on the web, it can be data about anything or everything. Can be a person, data about a person that you want to describe, right? Suppose this person, okay. Could be a car, an object, a physical object, could be about a country, could be about AIT, could be about a cat, a dog, could be about a device, gadget, and so on. Could be about the data, the piece of data, like a file. So everything should have URI. And URI means unique, right? It is unique. unique identifier. So every object is identified by a unique URI. It can be anything. You can come up with any mechanism for your unique URI. That's fine. Even it can be a random text or something. But if you can make sure that every time we refer to this random text, it's unique and it refers to you, then it is fine. Okay. And usually in an example, you will see URI in the form of URL. Because with URL, it has already some mechanism for you to make sure that it's unique, right? If I want to define something unique for myself, I might go and register my domain name. Then everything under my domain name is under my control, right? Nobody else should use my domain name to name something. So I might register, let's say, my URI. Suppose I just register my URI.com. And then I can name every of my object resource that I want to describe under or after this. Or if we think about AIT, AIT already owns, right? AIT.ac.th. So anything under this domain name of AIT, AIT could be very sure, right? Nobody else can try to use it for some of their own purpose, but it's under AIT management. So AIT could name could define the ID for the URI for every faculty, every student, every property resource that they want to register, every building, every classroom could have a URI with the AIT domain name, under the AIT domain name. They would need to define some mechanism like, okay, I would define, suppose I am managing data for AIT and I want to make use of linked data to connect all the data of AIT. I may use ait.ac.th/resources. And I may define mechanism of running this ID under the resources, right? But directories or further slash and so on to categorize many of my resources, such as resources and then staff, and then maybe student to categorize different resources. And then under student, we do have very unique student ID already, then that is fine, right? After this, every one of you may use this URI if we define as a standard way for AIT URI. So every one of you will have this URI to identify yourself. Then you can have your own URI that is for sure guaranteed to be unique. The same for any other object that you may want to describe. The first thing is you need to make sure it's uniquely identified by some URI. Okay. After you name anything, okay, we give them URI, then it is a resource on the web. It refers to a resource. By this mechanism, you can, okay, second principle that is kind of difficult to explain, but let me, once we have the URI, once we have the URI, okay, this thing says that we want to make URI dereferenceable. It means that actually concept of URI is just ID. Such as I already said, for me. I might okay. Let's say that this is my URL. Okay, this is me. Refer to me. But it looks like it is in the form of web address. And suppose I define this mechanism for every human resources, staff, faculty, student, and so on. We'll use this. It looks like it is address on the web, but if you type this in a browser, will you get something? You never, right? Because there is no web page for you to get this. So URI doesn't mean that there must exist a website, a web page, a web file, a web resource. No, it's different thing. Resource on the web is one thing that is referenceable, that is referred to by some URL. So that is why URI is very different from URL. With URL, you can use that address. You type in, it will show you something, or will refer to a file or something on the web, right? If it exists, if there's no 404 file error, file not found or something. But with URI, no, it's just a mechanism to give an ID that is universally unique. But people may want to get description of the thing, right? If this is my URI, what if you want to know about me? You may want to get a description about this URI, right? About this resource, about me. So that is the second principle for linked data. Everything should have a URI. But after you have a URI, you should be able to find a description of that resource. So if you want to know what is this resource about, you should be able to put this URI, my URI, in a website, web browser, and it should return the description about me. That's the second principle. Make the URI dereferenceable on the web. Return some description. For example, this is example of how people might think of URI mechanism. But then there are many ways, right? Let's try Bangkok. Okay. We talked about DBpedia yesterday. You can, what did I do? Is actually, Okay, what did I use? Okay, let's try this. Okay. Okay, actually, I am going to describe this. Okay, if we refer to DBpedia as example, I should have another one. Okay. Okay. Moment. Okay. Okay, it doesn't return as of now, but let's see, because the server is busy. Okay, I explain first and then we try the server later. Okay, what I want to explain here is that if we refer to example of data on DBpedia, link data on DBpedia that we discussed an example yesterday. When we talk about Bangkok, everyone know Bangkok. Okay, Bangkok is a thing, of course. It's considered as a thing. The very top most concept that everything belongs to is just that it is a thing. But you can classify further that that thing is a country, it's a person, it's an organization, it's a place, and so on. We can do some kind of classification under this, but apart from further classification, everything that we want to describe on semantic web is a thing. So Bangkok is definitely a thing. Bangkok has you need to have a URI for Bangkok. When you want to make it available on semantic web, and this is it. This is the URI for Bangkok. As I said, URI is just ID. It doesn't mean anything. It's just an ID. Every time people talk about Bangkok, as we said that there could be some ambiguity happen, right? In Thailand, there is a restaurant named Bangkok. There is a university named Bangkok. in many other places, there might be something named Bangkok. How do you know that when people say Bangkok, it means a city in Thailand? It doesn't mean a university nearby us. It doesn't mean a restaurant, but it means a city. Or if we talk about Cambridge, do you know Cambridge is not just one city in England, right? There are many Cambridge, other countries too. How do we know that which Cambridge do we mean? So anytime you want to be very specific to just something, Bangkok alone or Cambridge alone doesn't give you very specific. But if you, okay, the Bangkok, I mean, this Bangkok, this URI. If it is a Bangkok that is a restaurant or a university, maybe it will use a different URI. Then you can know that, oh, okay, I mean that Bangkok as a city. The other person may refer to that Bangkok as university. Okay, you differentiate them. You know the distinction by the URI. That's the first thing. But then the URI doesn't give you any description. The URI is just the ID. But people, when we say that it is semantic web, we want knowledge. We want description to understand what is that resource about, right? We talk about RDF, we talk about linked data. So we want to describe. In order to describe about the resource, if whenever you put the URL in, and it can return you a description of that URI, that ID. That is what we consider it to fulfill the second principle, making the URI dereferenceable. Put the URI in, it returns some description. So what I show as an example here is that actually you try by yourself using Bangkok URI, okay, with dbpedia.org/resource is the URI /resource/Bangkok. Make it capital, it's case sensitive. It will redirect you, kind of revert you to this one. But actually, that is the mechanism, one way to make the mechanism for URI dereferenceable. Anytime you want to know what is this URI for, put it in the web browser. It should return you some description, human readable description about that resource. So that is why I put resource here, but of course, it redirects to this description. So back to this, mean that here, okay, this is the explanation. Actually, the URI, okay, is to just identify things. But if you can look up using that URI and return a description, right? That is what we mean by making URI dereferenceable, okay? Retrieve some description of the resource identified by that URI. And in Wikipedia, DBpedia, sorry, DBpedia has 3 standardization of its own to do this thing. First, the resource or the thing will have this format of the URI. Everything will be under resource. And then by that unique name after that, resource slash. Could be a person like Joe Biden, Barack Obama. Okay, you need to find out how to refer to that Barack Obama, Joe Biden, Thailand, Nepal, whatever. And this resource will, after you put it in the browser, okay, API connection, anything, it will return you the HTML page for describing that resource, that thing automatically. Some other platform that make use of this principle, they may have their own ways to define the thing, the data, the page, and so on differently. But that is just what you may want to define locally, but you need to prepare this mechanism or provide this mechanism. Okay, so that is number 2. Okay, and then you can see that URI is one thing. Providing description is the second principle, right? Principle number 1, provide the URI for everything you want it to be identified on the web. Second, that URI should give some description when dereferencing, okay, through API, through HTTP protocol, and so on. Number 3 principle. When someone look up the URI, of course, number 2 is to return something useful in human form. But in this step, principle 3 is kind of another level, provide also in RDF statement format. And that is what I try to show you, but the server is busy and does not return as of yet. This is an example of RDF statement written in XML syntax. Okay. But in principle, it says that this is okay. This is the person URI. This URI has name, something. This URI has age, 25. This URI has gender, male. This is the way that is written here, and I draw as RDF graph. This is called RDF graph. The graph that visualize the resource description in a graphical notation. Okay, so actually, did I skip anything? Okay. Remember, whenever you refer to any resource by a URI, okay, this is that resource URI for this first one. Okay, I should. Okay, this is the resource. It has a link to this another resource. It has another link to this another resource. Okay, so in this case, we have 3 resources. If we count, these are 2 RDF statements. First, saying that this person owns this car. The second statement says that this person lives Thailand, right? Lives in this country, Thailand. These are the 2 statements. And everything actually you could see is formally represented by URI. Because if we use the word Audi, it could be something ambiguous, right? We don't know whether Audi always means the car or not. But if we refer to this URI, it is that Audi. Okay. If we refer to this URI, it must be that country, Thailand, not anything just named Thailand. If we refer to this URI, it is this person, particular person. Okay. And even the link or relationship, or in RDF term we call predicate. Even the predicate must also be URI. Why? Because even the meaning of a property or predicate, it can be ambiguous. What does it mean by owns? What does it mean by earns, by live in, by, it could mean different things. The scope or the meaning could be very different in some context or in some application and domain. So the relationship should also be uniquely identified, that we mean this. But some has very specific, some has very clear meaning, that is fine. But in some domain, it could mean differently, right? So it should be defined properly that, okay, I mean this particular relationship. Okay, so that's number 2. Let's try again, and I hope it works. Data doesn't work yet. Actually, it's full. Maybe we need to wait until they restart the machine. I don't know. Okay, but anyway, I don't know when will that happen. But what will return? Okay, what if you could see from this is that you could actually, it will browse you to another page, return you another page in which you can view the RDF statements about Bangkok, for example, in any of this syntax, any of these formal syntax, XML, JSON, total, entry, and triples, for example. Okay. I don't think we can view. Okay, we can view in this JSON. It works, but why not in the? Okay, let's try total. Total doesn't work. Let's try total here. So what does it mean? It contains too much or what? It doesn't return to us? Okay. I don't want. No. Okay, let's try some other day. All right. But anyway, it should be able to return you any different syntax of RDF like this, because what is shown to you here in this first syntax here, this is human readable syntax. This is actually not RDF, but still it is in a tabular format that allows you to see what RDF is underlying this. So it says that this DBpedia, okay, behind this in its data store is RDF, saying that there is the resource, Bangkok, with the URI dbpedia.org/resource/Bangkok. And then the property, populated place area metro with the value 7761.6. Also this area total with this value, and then the abstract with this value, and then area code with this value, and so on, and country Thailand. So you could see that actually every of these properties, they are URI as well, but it has a short form because URI is very lengthy. We will see how to make it a short form. The short form is through the use of what we call namespace and prefix. So we just make the prefix for such as abstract. This is the URI for abstract is this one, dbpedia.org/ontology/abstract. So what we could draw, okay, I can draw, is that for that DBpedia page, if we make it as so, actually the full URI is like this. Okay, this is the URI of Bangkok. Remember I said that it has and then refer to a long abstract. And then it has even, what else? Let's try something short. Country, DBO country. And then it refers to Thailand. Actually, what is that Thailand? It's not just the short terms, the keyword Thailand, right? But it is this long DBpedia URI. And actually, if you use this, you can draw the very huge RDF graph, right? Describing this Bangkok. And this mechanism, DBO colon, okay, we will learn in the later, but it's a mechanism to make prefix that this DBO could be a prefix stand for dbpedia.org/ontology. So every time when we want to write something shorter than the URI, we could use this short form with the prefix stuff. Okay, so that is why you see that yes, this DBO area code, as I said, but the long form of the URI is the whole thing. But it's not, it's too lengthy. Okay. Okay, so this is the graph, and that is the human readable description, and also there is underlying IDF description as well. And that is okay, we are up to here, guideline principle number 3. Every resource in linked data should have the IDF description, okay? And we talked already about IDF description, subject, predicate, object. And everything is in the form of URI, except that if it is literal. Okay. Okay, we already have this. Barack Obama has a birthplace in Hawaii. So if we represent this in RDF, it must be this triple: subject, predicate, object. So it's not really human readable syntax easily, right? But it's in the machine processable form. But if you understand the notation, the mechanism, the concept, you are also able to understand what does it represent in this RDF triple. Okay. And principle number 4, including links to other things. And this makes connectedness. Everything should connect. Now, if we define a person here, okay, this is a URI for something. How can I know that this is a person? Oh yes, because there is this description. Say that this RC secret has the type person. Oh, this must refer to a person. And this person resource has name Richard Sigurnier. He has base near Berlin. Okay, what does this mean? This may be personal web. This data could be available. I mean, this description could be available in a personal website of this person, right? It says that, oh, I am a person. I have this name. I am based near Berlin. But the way we refer to Berlin, if we define Berlin URI by our own, then it's just not connecting anywhere, right? It's just within the personal website, web space. But now this URI refer to DBpedia Berlin, mean that this web, this personal piece of RDF graph refer to the DBpedia Berlin. And actually, if you follow DBpedia Berlin, you will see that there could be similar description, hundreds of description, similar to Bangkok, right? About area, about abstract, about population, and so on and so forth. Then related information or knowledge about things can be provided by another resource description. And this make the network effect. You provide only what you know. You refer and link to other available knowledge, the knowledge available in other sources. But of course, you need to choose the best source, right? It's the same as you are writing HTML page. You may not include everything, but you link to existing page of some knowledge and some resource as well. So this is the principle number 4. And with this, it allows, and that is why it is called link data. Not only link within personal local space, but from some local space, it links outside to other resource and other space too. And that is why yesterday we saw this kind of link open data diagram. It says that most available data source, link data source, are linked, how they link and how big they are. For example, DBpedia, as I mentioned, is kind of nucleus. How can we spell nucleus? Okay, it's kind of a nucleus for every other link data to refer to it as well. Because when you want to talk about Thailand, Bangkok, oh, you just refer to DBpedia resource easily, right? And there are many others available too, such as geonames. These are for geographic locations. DBpedia are for almost everything, right? Fourth, these are for persons, people. Even US Census data, BBC, music, OpenPsych. This is open ontology project as well, WordNet, and so on, DBLP, okay, many other things. So try to link to other, and this makes the network effect. So in summary, okay, these are the 4 principles and kind of stepping stone. You need to achieve the first level and then achieve the second, and so on, and third and fourth. First, start with having everything identified by URI. Second, use HTTP URI that is dereferenceable, okay, so that people can look up and get useful information about that resource. Third, not only useful information in human format, but also in RDF, which is machine processable format. And then try to make your link data linking to others outside of your link data space. So these are the thing about link data. And as a summary, why this could be necessary or could be useful. Ease of discovery, easy for consumption, reduce redundancy, added value, and so on. Okay, I think the remaining are for reading purpose. Those who don't have some background or may need to refresh some understanding of HTTP, URI, XML, okay, please read further. And actually, this is also interesting or give useful information for you to read as well, okay? So the remaining of this slide, it will be for your own reading, but I put some of the key stuff related to XML knowledge in there for easy to understand and provide you as some kind of basic, okay? But there will be the references at the end that you can read more. Let me go to that. Where is it? No, I didn't provide in this. But anyway, let's have a break and then we come back and continue with another topic. But that is in RDF in detail. Okay. The next topic is about RDF.